Today, on how it's made. Racing shells. When it comes to making these boats, they're in it for the long haul. Stainless steel sinks. We plumb the depths of this story. Leather. We'll give you the story behind that good-looking tan. And pedal steel guitars. We'll have all the key techniques. Rowing can be a lazy and leisurely pursuit, or it can be about fast and fierce competition. The Racing Shell is a rowing boat that's made for speed. Long and exceptionally narrow, it's designed to cut through wave drag and leave the competition in its wake. Racing shells are made for single rowers, called scullers, for pairs, or entire crews. They're custom-made to precise specifications. Racers need to travel light to build up speed, so they make these boats from reinforced carbon fiber, which weighs a lot less than wood. They layer numerous carbon fiber sheets in a mold and trim them along the edge. They spray glue onto pieces of textured thermoplastic called honeycomb, then press it onto the carbon fiber plies. The honeycomb will serve as the core material for the boat. It will be sandwiched between layers of carbon fiber. It'll give the racing shell some lightweight reinforcement. Next, they vacuum the air from between the layers. They wrap the entire boat in a big breather cloth and a plastic bag. The breather cloth is a permeable layer that prevents the plastic from getting stuck on the mold, creating air pockets. Next, it goes into a long oven which melts glue impregnated in the carbon material, fusing the layers together. After 8 hours at 99 degrees Celsius, all is revealed. They pull the big plastic bag and the breather cloth away from the shell. Then they pry the boat out of the mold using plastic wedges. The boat comes out in one solid piece, and a primer paint sprayed into the mold earlier has adhered to the outside. They check the weight, which has to be precisely what the customer ordered. Next, they reinforce the boat's cockpit with several bulkheads, all of which are made of carbon fiber. They glue foam on the inside rim of the racing shell, using a piece of wood as a guide. They bead glue around the bulkheads. Then they lower the cockpit panel so that it adheres to the glued areas. The hard foam installed along the edges supports the cockpit. Next, using a computerized tool, they drill holes for the hardware and riggers, and they trim the rim from stern to bow. They smooth the finish using a grinding tool. And now, it's over to the paint station for some sanding and priming. They look for flaws and mark them for repair, because any imperfection could affect the speed of the boat and the mindset of the racer. Once the boat is perfectly smooth, they spray on high-gloss urethane. Next, they install a fin for a little stability. Using a laser, they align the fin with a guide to precisely position it. They insert a rudder in the bottom of the boat and attach it to a system of ropes the rowers can use to steer. This boat comes with special shoes, along with a sliding seat that allows the racers to put some leg power into their rowing. Finally, they install the rigging equipment for the oars. With all the work put into these racing shells, rowers can't help but get ahead. The stainless steel sink is an invention born of patriotism. It evolved during World War II, when sinks were often made from a copper-nickel material called Monel. When that metal was needed by the war effort, stainless steel was drafted for use on the home front, and it was such a good alternative that it's still on cleanup duty. Stainless steel is lightweight and heavy-duty, which makes it great for sinks. To make one, they uncoil stainless steel into a shearing machine, where large scissors slice it into pieces called blanks. They place a blank under a 1,000-ton press. As it descends, a punch rises from below. It stretches the blank into the rough shape of a sink bowl. Stretching the steel also transforms it on a molecular level, hardening it. Now they brush lubricant in and around the sink bowl to make it easier to stretch it again. The bowl goes under the same punch press, but this time it gets a more precise shaping. This second working of the steel hardens it a bit more. Now the sink goes under a different punch device. It cuts out a drain hole and forms a lip around it. Coolant flushes into the sink as an abrasive belt grinds the surface to give it a brushed look. They slide a sink bowl along rails into a welding machine. They butt a second sink bowl up against the first one in the welder. Inside, an electrode welds the two sinks together. Using enormous force, a roller moves across the seam to flatten it. A grinding belt behind the roller sands it down. The seam that joins the two sinks is now level and smooth. It's time to give the rim of the sink some shape. This die forms recesses along the sink's perimeter. The recesses give the sink a sleek look and collect water runoff. Another press trims the rim and gives it a bevel finish, which softens those rough edges. Now, using a punch cutter, they pierce the back rim of the sink to make holes for faucets and a soap dispenser. It's time to scratch the surface as they grind and buff the sink to a fine finish. This is a very intensive process that takes about 25 minutes. Using a hydraulic system, they emboss the trademark in a reverse configuration onto the outside of the sink, and it shows through in readable form on the inside. They block the drains of the sink with plugs and spray a substance similar to latex paint onto the outside. This finish will muffle the sound of dishes clattering inside, and it will also protect the sink from condensation. It takes about 2.5 hours to make a stainless steel sink. And now it's ready to go with the flow. Leather has a rugged appeal that actually dates back to primitive times, when humans rubbed fats into animal skins to preserve them. Times have changed, but leather continues to endure. It's strong enough to take a lot of abuse, so it's a very tough act to follow. This leather comes from the hides of cows killed for meat. Without tanning, the cow hides would go to waste. Converting them to leather is a kind of recycling. The first step is to cut each hide in half. They drape the hide over a sawhorse and then stamp an identification code onto it. They slice down the center. The two smaller pieces will be easier to handle and process than one large hide. They load hundreds of the hide sections into this modified cement mixer to undergo some serious hair removal. The mixer is filled with water as a worker dumps in a combination of sodium sulfhydrate and lime. A chemical reaction strips the hair from the hides. They bathe the skins in acid to prime them to absorb tanning salts. The tanning happens inside big wooden drums with prongs that keep the skins from getting tangled during the process. The chrome salts turn the hides a robin's egg blue as they bind to the collagen fibers of the skins. This converts them to leather. They feed the leather, grain side up, to a machine that splits it into layers. It slices the leather on the flesh side to an even thickness. The cut-offs won't be wasted. They'll be recycled into suede. They check each piece of leather with a gauge to confirm the thickness is uniform. Now it's into the wooden drums for a second tanning. But this time, they use a solution of vegetable extract, tree bark, and water. They add some dye and a chemical that will make the leather water resistant. The solution binds to the leather, tinting it a brownish tone. It's a gentler tanning than the earlier one, and it softens the leather. Now, they brush a mix of starch and water onto the tanned hides. It's a kind of paste that allows them to press the hides onto big frames of glass, which have also been moistened with the same starchy solution. Pasting the hides to glass is a way to hang them flat to dry. Wipers clean the glass between hangings, and a spray system coats it again with starchy paste. This method allows the hides to dry without shrinking and stops the ends from curling up. After 4 hours in a dryer, it's time to remove the hides. They easily peel away from the glass. A revolving paint gun system sprays the leather with dye to enhance the color. And now, it's time to create some friction. A glazing jack pulls a glass cylinder over the leather repeatedly, and the abrasive action polishes it. This glass is very strong, so it can do this vigorous work without breaking. Finally, huge heated rollers smooth out any wrinkles. It's the end of the production line for this big pile of leather. It will now be the stuff that many things are made of, and it's sure to live up to its tough image. It's quite a feat to play the pedal steel guitar. You have to slide a steel bar up and down the strings as you play them, while operating a system of pedals and knee levers below. This means using both hands, both feet, and both knees. It's a real performance. The pedal steel guitar has a unique sound and an impressive musical range. To make a custom one, the guitar maker carves the neck of the instrument from hardwood. He beads glue around the edges of the neck and applies strips of intricate wooden inlay. Once the fretboard design is silk screened onto the top, the guitar neck is complete. He outlines a design onto aircraft-grade aluminum and cuts it out to make an end plate for the guitar frame. He pops the end plate out of the holding device. He welds it to the rest of the framework and polishes everything to a mirror finish. Next, he machines a part called the steps. These holes in the steps will be used to attach tuning pegs. There's one for every string. He attaches the steps to the neck just above the fretboard. This is the pickup plate. It will hold the pickup that transfers sound to the amplifier, as well as a series of metal fingers. To make those fingers, he machines several parts from aluminum and assembles them together. The fingers pivot to raise and lower the pitch of the strings. He fits all the fingers in the slot in the pickup plate and secures them with screws. He double-checks the movement of the fingers, then hooks springs to the end of each one to maintain the proper tension. A little grease ensures this next operation goes smoothly. He shapes a part called the cross shaft using a special cutter. Then he moves on to the guitar undercarriage to build a system that moves the fingers with foot pedals and knee levers. He screws several cross shafts, one for each pedal, into the undercarriage. He attaches bell cranks to the cross shafts, and he connects thin steel rods to holes in the fingers and the bell cranks. This system will allow the performer to tighten or relax strings while playing. It's a kind of open tuning, and it's what gives the instrument its characteristic sound. He checks the knee lever to make sure it works. Here, he is winding copper-coated wire around a cartridge thousands of times. He's making a pickup, which transfers sound from the guitar to the amplifier. He takes two of the wire-bound cartridges and places a magnet between them to complete the pickup. He fits it in the other slot in the pickup plate, just above the fingers. Now, using a gauge and a level, he adjusts the pickup. It has to sit low enough in the slot that it won't interfere with the strings. There's no room for error here. The positioning must be exact, or the guitar won't sound right. He attaches 10 to 12 strings to the guitar neck. Some instruments have 2 necks to add even more dimension to the sound.